IGCSmart. Today we are talking about binary addition. So, binary addition has a certain set of rules. So these are the rules that you need to know. First of all, 0 plus 0 is equal to 0. 1 plus 0 is equal to 1. 0 plus 1 similarly is equal to 1. And 1 plus 1 is equal to 1, 0. I will explain what all of this means in a moment, but what's very important right now is just to take note of this concept. Okay, so let's put this in a square. Boom. Okay, so let's try to add some binary together. So let's go, we're adding 1, 0, 1, 0, 1, 1, 1, 1, and we're adding it to 0, 0, 1, 1, 0, 1, 1, 1. There. Okay, so now here's the hard bit. So 1 plus 1 is 1, 0. So we put a 0 here and we carry the 1. Oh yes, I forgot about another rule. 1 plus 1 plus 1 is equal to 1, 1. There, I will just extend a little info there. Okay. 1 plus 1 plus 1 is equal to 1, 1. So we carry the 1 here and we put a 1 here. Again, 1 plus 1 plus 1 is equal to 1, 1. We put a 1 here, we carry 1 here. 1 plus 1 is equal to 10. Put a 0 here, carry 1 here. 1 plus 1 is equal to 10. Put a 0 here, carry 1 here. 1 plus 1 plus 1 is 1, 1. Put a 1 here, carry 1 here. 1 plus 0, well, it's obviously equal to 1. And 1 plus 0 is equal to 1. So we get this binary. Now, it is very, very, very easy to check binary addition. And that is by purely converting this binary into denary and this binary into denary. So let's do that. And then, of course, converting what we got into denary as well. So 1, 0, 1, 0, 1, 1, 1, 1. In case you don't know how to convert binary to denary, we do have a really nice video covering that topic, and it will just be linked right now. Okay, so now we have to write out our usual table. 1, 2, 4, 8, 16, 32, 64, 128. All right. So now we just, once again, as I showed in the video, we go 1, 2, 4, 8, 32, 128, and we have to add all of these together. So we get 160 over here, plus 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. 160 plus 15 equals 175. So we get 175 as this one. Let's just write it in red over here, equals 175. And let's convert the second one. So 0, 0, why did this do that? No, it doesn't. Okay, 0, 0, 1, 1, 0, 0, 1, 1. No, I'll just do that. And that. Okay. So, we once again draw our table, and you'll be drawing many of these tables throughout the GCSE computer science course. So get used to drawing them. I drew them on my actual exam paper when I was doing it, and it does help, I must say, because you don't get confused. Okay, so 32 plus 16 is 48. 48 plus 4 is 52. 52 plus 2 is 54. 54 plus 1 is 55. So all of this is 55. Okay. 175 and 55. And the binary in the bottom that we got is, oh, that was weird. Okay. Let's once again draw our table. Always remember to draw the table, it just helps you. Until you know which one is which, which I knew when I was taking the exam. Now I once again forgot all of my wonderful shortcuts that I established. But yeah, until you are absolutely fluent in binary, do not stop drawing the table. The table will help. Okay, so 64 plus 32 is 96. 28 plus 96 plus 4 plus 2 is 6. 6 plus 96 is 102. 128 plus 102. Therefore, 230. There. And we got 230. So now what we can just check is we can say, okay, well, is 175 plus 55 equal to 230? And yes, it is. So we did the binary addition correctly. Put ourselves a nice green tick. So yeah, that is binary addition. And this is one of the easier questions that you would get. And really, 99.9% of the time, they don't give you harder questions. I've seen past papers where they are very evil, and they will give you a question that looks like this, a seemingly simple binary addition. And so you'll do your usual, like 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 10, carry the 1, 1 plus 1 is 10, 0, carry the 1, here you get the 1, and here you get 1, 0. Now, you might be able to see something here, right? And that is that we've got our 8-bit binary, we've got a byte over here, and then we've got this random bit over here, which is just sticking out. So what this bit is called is, this bit is generated by something called an overflow error. And this is key for the exam. They ask you about overflow error almost every past paper. So overflow error is when from an addition, or like from a binary process, we get that a bit which cannot be stored into the register is created. Because here we've got an 8-bit register, right? We've got a byte of data. And this one just absolutely breaks up our byte, because we cannot shove 9 bits into 8 bits. That's technically impossible. So what the computer usually does in this situation, and you don't need to know this for the GCSE, is it just creates a separate byte purely for this 1 bit. Or if it was representing it in hexadecimal, once again, link over here to it. If it was representing it in hexadecimal, it would just add 1 extra nibble over here. Once again, I'll remind you, a nibble is, a nibble is 4 bytes. Oh, 4 bits. Oh my god, 4 bits. A byte is 8 bits, and a kilobyte is 1024 bytes. Okay, so that's overflow error covered. What else do they give you in exam papers? Oh yeah, I've seen one past paper where they were very, very evil. And what they did is they gave you 3 binary things. 3 binary additions to do. So they would go like blah, 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 la, 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 boom, boom, boom. And then they would give you another one. There. And this just makes your life 20 times harder. There are two ways to approach it. If you're not very good at binary addition, then I would recommend to first add these two, and then add the sum that you get from these two to this one. The answer will still be correct, and it will just be simpler. Another method is just to go for it, right? And I just went for it on the exam because I'm pretty good with my binary addition. And so let's do this over here, and then I will do the second method as well. So let's label this the first method. So the first method is just to go for it. 1 plus 1 is 10. Put a 0 here, put a 1 here. So far, so good. Now, 1 plus 1 plus 1 plus 1. This is where it gets very challenging, right? Why? because here we have to really engineer. Well, we cannot, of course, we cannot say there's 20, right? Because, like, you know, 1 plus 1 is 10, and then another 1 plus 1 is 10. Therefore, 1 plus 1 plus 1 plus 1 must be 20. No, that's not binary logic. Binary logic works very, very differently. And so 1 plus 1 plus 1 plus 1 in binary is 1, 0, 0. So we put a 1, we put a 0 over here, then we put a 0 over here, and we put a 1 over here. So 0 plus 1 plus 0 plus 1, well, that's just 1 plus 1, which is 1, 0. So we carry another 1 over here. Now 1 plus 1 plus 1 is 1, 1. All of us know that. 1 plus 1 plus 1 is once again 1, 1. 1 plus 1 plus 1, once again 1, 1. 1 plus 1, 1, 0. 1 plus 1 plus 1, 1, 1. And again, we've got our overflow error. And this is, I'm pretty sure this is called the overflow bit. If I'm wrong, there will be a big window popping up on the screen saying that I'm wrong. So yeah. Okay. So is there anything else to binary addition? I don't think there is. So thank you for watching, and see you in the next lecture by IGCSmart. Thank you.